Okay, we're going to finish out our chapter 13 today by looking at our last couple types of renewable energy, which are geothermal and wind, and then we're going to also touch on fuel cells. So we're going to start with geothermal. If you take a look at this, geothermal means heat from the earth. So geothermal is heat from the core of the earth. So that's what we're focusing on today. Now, most of the time where you're going to find geothermal power on a large scale is at plate boundaries. So Iceland is a leading country in geothermal because they sit right on top of that divergent boundary. So they are right on top of a plate boundary. Now, typically what we'll do is we'll use heated groundwater to make this happen. So I'm going to jump forward to take a look at a diagram, and then I'll come back. So here, this is taking a look at geothermal, where we take heated groundwater, we pump it up, and we pressurize it to make steam. That steam is used to turn a turbine, and that turbine is connected to a generator to make our electricity. Now, one of the key things about geothermal is this is considered to be a non-consumptive use of groundwater. So we take that heated steam then, and we have a cooling tower that's used to condense that steam back into water so we can pump that groundwater down. Because remember, groundwater can take thousands of years to recharge. So we want to make sure that we're not using this up. So we pump hot groundwater out, pressurize it, use it for steam, condense that steam, and then pump that hot water down. So the only waste product really is the steam. So from that cooling tower, you will have some heat that's given off in the form of steam. But this should be a non-consumptive use. Now, this would be geothermal on a large scale. Now, we can also use geothermal on a small scale with heat pumps. And so we talked about this a little bit when we talked about countercurrent exchange, that with a heat pump, what we're doing is really taking advantage of the constant temperature of underground. So this could even be in a home, where when you want it to be cooling, say in the summertime, what we'll do is we will pump our warm air down, and then that's going to be warmer than the ground. So the heat will leave the pipes, and then the air coming back in will be cool. So that means your air conditioner doesn't have to work so hard. Now, when you want it in the heating mode, what we're trying to do here is raise the temperature that we're heating a little bit. So we pump cold air down into the ground, where now it will be relatively cooler than the ground because the ground stays that constant temperature. So heat flows into the pipes so that when your heat is turning on, now that heat doesn't have to be raised as high. So a heat pump really takes advantage of that constant temperature of underground and uses it to reduce the temperature change from either air conditioning or heating. So that's what a geothermal heat pump would do for you. Now, geothermal in the United States is not all that prevalent because, we need those tectonic plates. So our most tectonically active area is going to be out west. So this is the region where you're going to see the most geothermal power generation. For places like us, you might just be seeing small-scale geothermal heat pumps, but you won't be seeing that on a large scale in our area. Now, the pros and cons of geothermal: no air or water pollution. But again, remember, that's just me being shorthanded here. So you need to make sure you're saying no CO2, no SOx, no NOx, no particulate matter. You have to be very specific in the air pollution that it doesn't create. But the disadvantage is the setup, and it can be very expensive. So it can't be done everywhere, not for a large-scale power plant. And because you're dealing with groundwater, sometimes the maintenance cost can be expensive because that groundwater might have a lot of minerals in it that can be pretty corrosive to your equipment. So you might have to find that you're replacing pumps or pipes often. So those are the pros and cons, and really the biggest con is that setup. It's just not possible everywhere on a large scale. Now, one thing that I actually see a big future in for renewable energy is wind power. Now, wind power can be produced in a lot of places, and it has the most potential for growth. Really what you need for wind is about a constant speed of about 15 miles per hour. When you really break it down to what wind is, it's produced by differences in temperature. So wind is really caused by air moving from a high pressure system to a low pressure system, and those are governed by temperature. So the reason why I want to bring that up is because 4 of the 5 types of renewable energy sources that we've talked about are all tied to the sun. Clearly, solar power is tied to the sun with both passive and active solar power. Biomass is tied to the sun because of growth of plants. Water is tied to the sun because of the water cycle and the need for evaporation. And now here wind is tied to the sun because it's tied to a difference in temperatures. So the only type of our renewable source of energy that is not directly tied to the sun is actually geothermal. So that is just an important link to make between all of these. Now, one big potential for growth that we have with wind is that offshore potential. If you think about going to the beach, you often go there because it's cooler, because there's a constant wind. And the reason why we have that constant wind offshore is because of difference in temperature and how the land and the ocean cools at different rates. So that's going to pretty much always provide some type of a wind just offshore the beach. Other big places that you might see wind are on the tops of mountains or in our Great Plains areas. So we do have a lot of potential for growth with wind. Now, our big pros and cons with wind is no air or water pollution. And again, that's me cheating. You can't say that. You're going to have to be able to say no CO2, no SOx, no NOx, no particulate matter. Now again, this is from the use of wind. If we take a look at this diagram again, these are big giant blades. These are huge structures that have to be constructed and transported to where they are. So part of the whole cycle of wind does create pollution. But essentially here, this is just how we make electricity with, say, water or even coal. We're just skipping that heating of the water steps. Here, wind is turning this turbine, and right in here is a generator. So this cuts out those steps, which is why we talk about wind being efficient, because you're just turning a turbine by the power of the wind, and that turbine is connected to a generator. Now, wind farms are relatively inexpensive when you think about the price, say, of a nuclear power plant or a coal power plant. Now, they are individually pretty expensive, but overall, the cost really greatly diminishes as you get more power per year. So some of our disadvantages, they are site-specific. You need that constant and significant amount of wind. So it's not a viable source of power anywhere. And very similar to solar power, there are going to be times when you don't have wind. So you will want to have some type of a backup energy source or a battery. Now, some people don't like the way they look, so we say that it has aesthetic degradation. A lot of people on coastlines are trying to fight having these offshore wind turbines built because they say it's going to take away from the beauty of their beach or their view. And then finally, you might see some harm to birds and bats. And the problem here is that birds and bats, they might be able to see a wind turbine when it's standing still, but as the blades turn, they may not be calculating for that. And there have been instances where birds or bats are found dead at the bottom of a windmill. But there are some fixes to this. Make sure they're not in migratory patterns of birds is one big thing you can do, or have some type of a sound that might discourage birds or bats from being near here. But that is a problem. It's not very significant though. Now finally, what I want to finish with are fuel cells. So fuel cells are considered to be renewable because our primary source of fuel is hydrogen. And there is a way to split water and create hydrogen and oxygen. So hydrogen could be a pretty unlimited fuel source. And so here we're converting chemical energy directly into electricity. And what we use is hydrogen and oxygen. So our pros is it's efficient, and by that I mean because it's just one step to creating electricity, but it's not very powerful. Another issue is getting that hydrogen. We just don't have like hydrogen fuel stations. So the distribution and getting that hydrogen is a problem. And the actual getting hydrogen, you might have to supply some electricity to be able to split that hydrogen from the oxygen. So actually getting the hydrogen and then finding fueling stations for it, this is a problem. But what we're mostly looking at fuel cells for are cars. And then how a fuel cell pretty much works is you'll have an anode and a cathode. So if you remember, these are negative and these are positive. And in between those, you have a catalyst. Now what's going to happen is this catalyst will exclude electrons. So when I supply my hydrogen, the protons are able to go through the catalyst, but the electrons are excluded. So they have to flow through a circuit. And really, electricity is a flow of electrons. So the hydrogens flow through, the electrons are excluded, and then we have an acceptor over here with oxygen. So when the protons and electrons of that hydrogen meet up again, join up with oxygen, then our only waste product is water. So this has the potential to be a very clean, reliable source of energy if we can find ways to get a little bit more power from these. Right now you have to have so many in a car that it makes it kind of heavy. But this could be potentially a very clean source of energy using only hydrogen as a fuel source. So we'll do our graphic organizers to wrap this up, but these are our renewable sources of energy. So other things I want you to be thinking about are ways that we can encourage people to use more of these renewable sources of energy.